So I guess any mono. Is that true? Yes, I think it's true. Classifying space. So in particular, this one has BGK. So then, maybe in the middle. So BGK. And then homotopy classes from X to BGK are now in one-to-one correspondence with spherical K-1 fibrations. And the reason I started talking about Whitney sum is because we want to do the same thing again. We want to find a universal classifying space. So BG is defined to be the limit of BGK by fiber-wise joining with a trivial sphere bundle. So let's call that, I don't know, alpha fiber-wise join a trivial thing. So I don't know, what's the best way to write this? This goes to alpha fiber-wise join epsilon, so this is going to be in BGK, this is going to be in BGK plus 1. Okay, so we've got some kind of stable classifying space for spherical K-1 fibrations. So I guess a couple of things to note. We've got, like I say, a spherical K-1 fibration for every K-plane bundle, which means we've got a map from OK into, let's say, BOK into BGK that just forgets the fact that it was a vector bundle. So this is going to be important later. GK. What's the time? Oh, okay, so I think I'm going to talk briefly about the Pontryagin-Thom construction and then finish slightly earlier than I usually do. Okay. So I know Carmen talked about Pontryagin-Thom, but I wanted to have it on the top of everyone's minds. So I'm just going to sort of reiterate it, because it's going to be really important. Okay, so Pontryagin-Thom construction. Okay, so recall that any closed manifold here has a stable normal bundle. So we can take a representative. So that is to say we can take an inclusion of M into some high-dimensional Euclidean space, so that I guess the pullback of the tangent bundle of this thing is isomorphic to tangent bundle of M. So I'm just going to call this normal bundle of M and know that it means relative to this embedding. Embedding. That's important too. Okay, so then I've got the tubular neighborhood theorem. Neighborhood theorem. So this says that there's a diffeomorphism between a tubular neighborhood of my manifold and the disk bundle of the normal bundle of M relative to the sphere bundle. So this is a diffeomorphism. So the point is so this sort of thing exists abstractly, but I'm trying to physically embed it somewhere so that I can get my hands on it. And then the collapse map. So this is all sort of in the theme of what sort of properties of vector bundles do we want to mimic in the spherical fibration case. And it turns out this is the crucial property. So the collapse map. So this is the map that goes from Rm plus k, and I'm going to point compactify that. So this is a sphere. So that goes to, where do I want to go that to? Tom space. So I'm going to put that in the Tom space of the normal bundle. So the way I'm going to do that is send everything outside this regular neighborhood to infinity in the Tom space. And then I'm going to send everything on the interior of the regular neighborhood to these objects, and then the quotient via this diffeomorphism. So this is going to be a diffeomorphism on the inside of the regular neighborhood. So I want to send, so send, I guess, the interior of the normal neighborhood to the interior of this thing, and I guess the boundary goes to the boundary. So I'm going to send the boundary of Nm to Snm, and then I'm going to send otherwise. It's going to go to okay, so then I guess this goes to the Tom space in the normal way by the quotient. And then everything else is going to go to infinity. Okay, so C is a diffeomorphism on the interior. So this sort of wandered slightly, but I don't have that much else to say, so I'm going to write up here. So claim. The induced map on homology sends the class of the sphere to a generator. So this is kind of easy to see, it just falls out. So C is a smooth, what do I say, degree 1 map as every point on the interior of this neighborhood. No. No, this isn't quite right. I'm going to keep going anyway. Every point in the interior of this thing, let's say, has one point in the pre-image. So degree 1 means that I'm taking, what am I taking? So this is Z obviously, and this should be Hm plus K of, I guess I want to say reduced to the Tom space. So this is Hm plus K of this thing relative to, it's fine, which is going to be Z. So it's a degree 1 map, so it's got to send a generator to a generator. And I think that's everything for the first half of the talk.